Hello, my name is Amir. Our project team, EinsUndNull, would like to represent a prototype for real-life solution. The problem is that there are millions of people who die in car accidents, and the reasons may vary from the human part or the road part. There could be obstacles that surprise the driver, something like sudden pitfalls or problems of low brightness. So as a solution, we designed a smart car controller that interacts with surroundings of roads. We use an ultrasonic sensor which detects the distance. We use an ultrasonic sensor to detect the distance between the car and any obstacles in front of the car. Something like a wall in front of the car will make the car stop completely.
My name is Hussein. We use the H-bridge, full H-bridge to control the four wheels of the car. One for the two wheels of the car and one for the front wheels of the car. The H-bridge is getting its signal from the antenna. There are three signals which they are getting. One for the stop, where there is a huge obstacle in front of the car and it can pause it. There is another signal for the slow down, where there is an obstacle in front of the car, but it can pause.
My name is Muaz. In our project, we are introducing using ultrasonic to predict whether there is an obstacle in front of the car or not. So the ultrasonic sends signals and see whether there is a pitfall, and if there is a pitfall in a range of 2.3 meters in our prototype, it will force the motors to down to its 80% of its original speed.
As we can see, our ultrasonic sensor has three levels. The level that the car can use its full speed, so that LED is on. And if there is an obstacle that the car can pass over it, so it will go to level 2, that the speed will go down to 80% of its original speed, as you can see like that. And if there is an obstacle that the car can't move or pass over it, so it will stop immediately, and that is our last level.
So in our project, we tried to make the car turn its light on when the round light was very low, and to turn its light off when it's very bright. So what we used LDR, which is light dependent resistor. How it works? It works with an output digital output. If the input luminance is very high, I mean light intensity, then the resistance will be very low and the voltage is high, so the digital output will be high. Then the resistance will go high, means low voltage, low digital output. So we connected it to the Altera board. So when the light is very high, the output will be 1, and the Altera board will, when it see an input to it, which is the output of the LDR. The input, if it is 1, then its output to our light, which is connected to the pin, is low. And if the output of the LDR is 0, which means low light, then it will be the input to the Altera board, and the Altera board will output to the pin, which is connected to our light, to high. So it will turn the light on.
Hi, I'm Amar Adil. So now we're going to collect all the parts together in order to know how the car works. First of all, this is the light sensor that works when it gets dark. The second part is the optical avoiding sensor, which is the ultrasonic. The ultrasonic sends its signal to the Altera, and then the Altera processes this signal and enters in one of 3 levels. The first level is there is no obstacle in front of the car, so it can go on. The second part is the obstacle is very close from the car, so it slows down. And the third part is the obstacle is very close to the car and can't go over it, so it stops completely. If there is no obstacle in front of the car, the motors go with its full speed. If there is an obstacle in front of it, it slows down and stops completely if the obstacle is very close from the sensor.
So after we introduced our project to you, to conclude, it's just a smart car which interacts with its environmental surroundings.
So these were our solutions that can be interpreted into a real-life solution in order to reduce the percentage of car accidents.
Drive safely and have a nice day. Thank you.